All right, so today we're going to go over how to use the wave speed equation to figure out different things about waves. So this is the wave speed equation here. If we look at the wave speed equation, we have velocity. So in other words, the speed of a wave equals, let me rewrite that. The speed of a wave is equal to the frequency of the wave multiplied times the wavelength of the wave. Okay. In other words, frequency times wavelength gives us speed. Okay, so these are the units. For speed, we're going to have the units meters per second, which makes sense because we've seen V already, right? It's for velocity, basically. So V equals speed, meters per second. Wavelength is, remember, wavelength is how far the top of one wave is from the other wave. Whenever we're measuring distance, we measure that in meters. That's why the wavelength is in meters. Okay, so that's the unit for wavelength. Then we have frequency, which is waves per second. Okay, frequency stands for waves per second. So remember, something that looks like that would have a, sorry, let me redo that. Something that looks like this would have a high frequency. Something that looks like that would have a low frequency. Then we have this, similar to when we did the speed problems, you guys can use this triangle here to figure out either frequency, speed, or wavelength. So towards the first problem, for the first problem, I'm going to break it down in more detail, and the next ones are going to be a little bit more quick. So the first problem, so we have a first problem that says, a wave traveling at a speed of 230 meters per second has a wavelength of 2.1 meters. What is the frequency of this wave? So in this problem, we're trying to find the frequency of the wave. So I'm going to list everything out. So I know that the speed is 230. We can put the units right now if we want, meters per second. We know that the wavelength is 2.1 meters. Okay. Frequency, we don't know, so we just put a question mark. All right, so I'm going to solve this problem using my speed triangle for waves here. So if I'm looking for frequency, that means I'm going to block frequency. So if I block frequency, that gives me frequency equals speed divided by wavelength. Okay. So in other words, frequency is going to equal my speed divided by my wavelength. So it's going to be, we can put units at the end, that's going to be 230 divided by 2.1. Okay. If you can right now, pause the video and then try to put that in your calculator, see if you get the same answer. So I'm just going to go ahead and I'm going to put that in the calculator. I'm going to go 230 divided by 2.1. It's going to give me 109.52. No, a few other numbers, I'm just going to round to the first decimal. So I'm going to go 109.52. So I'm just going to leave it there. Okay. Last of all, I have to put my units here. So it's frequency. So my units are going to be hertz, waves per second. Okay. All right. I'm going to do another problem, but I'm going to do this problem. I'm not going to use the speed triangle. So let's see what we're asking for here. It says a wave with a frequency of 500 hertz is traveling at a speed of 200 meters per second. What is the wavelength? Okay, so let's go ahead and we're going to list what we know. So we know the speed is 200. Wavelength, that's what we're looking for. Frequency is 500. So I'm going to use our original equation, which is V equals frequency times lambda. And I'm just going to plug in what I know. Well, I know speed. My speed is 200. So 200 equals my frequency, which is 500 times lambda. So in this method, I'm not using the triangle. It'll give you the same answer, but I'm just plugging and then rearranging and solving. Okay, so now I want to find wavelength. So that means I have to get this. I have to basically get this 500 and get it to the other side so I can get this by itself. Okay. All right, so what I'm going to do is well, Right here, I'm multiplying times 500, so I have to do the opposite, which is going to be divided by 500. So if I divide by 500 to one side, I have to do it to the other side. So 500, this same thing over each other cancels. So that gives me wavelength equals this. So if I put that in the calculator, wavelength equals 200 divided by 500. 200 divided by, should be a small number, gives me, my answer is going to be 0.4. It's wavelength. If we double check, it's distance. So my units should be meters. Meters. Okay. You don't always have to list this out. I do want you to do it for some of the practice problems though. Okay. So for the problems in your work, in your homework, you do have to make sure you're showing all your work. Let's work through this problem. So I'll kind of go through this one more quickly. We won't set everything up. We have a wave that has a frequency of 900, so that's my F value, and the wavelength of 200, so that's my wavelength. What is the speed the wave is traveling on? Well, I know speed equals frequency times wavelength using the same equation. Well, if I'm looking for speed, I'm looking for this. It's already by itself, so I just plug in. So I just go 900 times lambda, which is 200. That would give me my wave speed. So I put that in the calculator. Gives me 900 times 200. Gives me a speed of 180,000 meters per second. That's speed, meters per second. Okay, so right here I'm just plugging in solving. If you were to use the triangle, you would get the same answer because it would be, remember this is a multiplication sign here. So if we block this, speed equals frequency times wavelength, same thing. You would get the same answer. Okay, so remember this is a multiplication sign. Actually, I'll just leave that there. On the bottom is a multiplication. Let's go over this last one. So it says, a fisherman notices that one wave passes the bow of his anchor every 3 seconds. Okay, so this problem's going to be a little bit more difficult. He measured the wavelength to be 8.5 meters. How fast are the waves traveling? So if we have, well, we know that this is wavelength, this is lambda. We're looking for wave speed because he's asking for how fast. This top information, it tells us that we have one wave per second. So if you remember, frequency is waves per second. So in other words, my frequency equals one wave. So one wave every 3 seconds. So I have one wave every 3 seconds. Okay, so this would be wave here. So if I put that in my calculator, that's going to give me 1 divided by 3. 1 divided by 3 is going to give me it's going to give me 0.33 repeating. Okay, so that's my frequency because it's one wave passes every 3 seconds. Now I can solve for speed because I know speed. I know that my speed equals frequency, which is this, times my wavelength, which is this. So I just go speed equals 0.33 multiplied times my wavelength, which is 8.5. It's going to give me 0.33 times 8.5 gives us a speed of 2. I'm around to the first decimal. That's what I want you guys to do for the work. 2.8 meters per second. Okay, so for the worksheet, you can either just plug it into the equation and solve, or you can use the triangle, but either way, you do want to show all your work. Okay, you don't have, for some problems, you can show this. You don't have to show it for all of them, but I do want you to show this work for all of them. Okay, and this is going to be due on Friday, so you have today and you have tomorrow. Let's try to get this done. Okay, if you have questions, just send me an email. Make sure you keep it up to date. This is going to go in your quarter 4 grades. If you have any questions on that.